So you can find in your WhatsApp, I attached two documents. One is for binary classification, two classes, and one is for multi-class classification. Now today we will be focusing on binary classification, but multi-class classification uses many of the same techniques. It just has some additional steps. So both of these are for your reference. So please download. They are also in the tiny URL Google Drive under Documents. So you should find them there. Okay. So today, what I want to do is briefly overview the steps of binary classification, and then introduce the two notebooks, Notebook 3 and Notebook 4. Notebook 3 covers some of the preliminaries, the preliminary steps for setting up your machine learning model. Notebook 4 goes through the entire process described in this document from beginning to end. So Notebook 4 is worth your while to study. It takes you through the entire process of a machine learning classification task. Right? So let me go over this outline that I sent, and please open on your own system as well. It's called ML Binary Classification Modeling. It's on the WhatsApp. Okay, so I'll open it on my own system. And I do want to encourage you to put all your materials in one place. Don't put on your desktop. Put everything in one folder, in one special place, so that you can know where it is and recover it. In fact, I'm going to put these two PDFs in a separate subfolder. I'll put them in my documents. Whoops, sorry. I'm going to make a new folder and call it document and put them there, because I do want to organize my folder. So I put them in there, and then we'll go through this one together, binary classification. Okay, all right. So some of these are common to any kind of statistical study. Okay. And please, I think that what we can do, so I guess what I'll do is I'll go through the outline and you look it over, and if you have some questions, you can write down your questions we can answer. Or if you have questions while I'm talking, you can raise your hand. All right, so first, frame the research question. Number one, state the outcome as a binary event with a clear time allocation. Value, those have height below a certain value. Those who have got malaria within a certain time frame, those who did not get malaria within a certain time frame. So you need a clear binary criterion where people fall in one class or the other, right? Okay. And here it says confirm the outcome is knowable from features available at prediction time. Okay. Right. So you will only want to be able to use features that are available for the prediction, right? You don't want to use some factor that's not going to be available to you to predict other data. For instance, if I want to predict someone's height at age 5, I'm not going to use their height at age 10, because their height at age 10 is not available to me when they're age 5. Okay, so you want to phrase the outcome in terms of factors that are available at the time when the outcome will be determined. So decide what the model is for, ranking individuals by risk, producing calibrated absolute probabilities, or both. Okay. Now we'll see examples of this in Notebook 4. So I'll leave the explanation for notebook 4. Okay, so that's first, frame the research question, right? Second is understand the data before modeling. And I have been emphasizing that this is an important step. Can I get rid of this? Let's see. Just move it out of the way. Okay, right. So you want to look at the variables. You want to take raw statistics, mean, median, standard deviation, draw graphs, understand your data. Okay. Okay. Now, one issue with real data is missingness. Sometimes data has NA. So you need to distinguish whether the NA in your data is because of a certain structure or because the data was not taken. So I will show an example of this in Notebook 4. Okay. So you may need to remove data that's missing if the missing data is not structural. But structurally missing data you can retain. Okay. So I'll explain this more in Notebook 4. Okay. May have data with features that are not relevant. Okay. So, for instance, you might say that if someone who is getting malaria, you might think that diet is not relevant or height is not relevant. So you should decide on the grounds of practical grounds whether features are going to be important or not. Now, in fact, there are more systematic ways of selecting features, and we may get into that in later notebooks. You can measure feature importance and select the features that have been found to have feature importance. So this part here, there's a rich variety of different techniques here. But the easiest technique is simply identify the features that you think are important for the outcome that you are measuring. Right? Like I said, if someone likes eggs, that doesn't have anything to do with whether they're going to get malaria, right? So you would not use that feature in your feature set. Okay? Right? Now, in order to treat the features, you need to classify what they are. And I think that that's been gone over in other sessions: continuous, binary, ordinal, or nominal. Okay? This is important because then you need to use this information to encode, to pre-process the data. Okay? That's a subsequent step. Okay? And then drop rows only for defensible reasons. So if you have unknown categories or you have missing data or missing data that's not structural. Okay, so so here is put together your list of features. Okay, are we good so far? Okay, again, we will see all of these steps in Notebook 4 and some of them in Notebook 3. In fact, all of these you'll see in Notebook. All right, handle missing data. So it says for structural missingness, encode explicitly. Okay. Sometimes not applicable actually has a meaning. Again, we'll see an example of this. So you need to re-encode. But for genuine missing data, you can either impute or you can remove. Right. Here again, there are many techniques. I think in Notebook 4, we do not impute because there's no actual missing data. So later notebooks, we may talk about imputing. So all of this, all of these so far can be described as preparing and cleaning the data. Okay. So you want data you want data so that you have a value for each data column, and also each data value is relevant. Okay. So finally, once you've determined these things, you want to encode the features. Okay. So you can use standard scalar. The reason for encoding is that these different types of data have quite different characteristics. For instance, a continuous variable might take values from 0 to 1,000. How are you going to compare that with a binary variable that takes values from 0 to 1? You want to put them on a common scale. Or if you have nominal data, how are you going to compare that to a numerical data? So one way to do that is one-hot encoding. I covered that in an earlier session. Okay. So you encode based on feature type, and then you assemble with column transformer. This is a function within scikit-learn. Okay. Now here, when we formalize the process, here it says three-way split is good. Sometimes it's two-way, but usually it's three-way: train, validation, and test. Validation is for preliminary evaluation of multiple models. Once you train, you will train multiple models. The validation makes a preliminary determination of which is best. Then you take your best model and you put it on the test set. Okay? So there's really two stages of testing. As I mentioned, validation is like quizzes. Okay? And test is the final test. Test set gets separated completely. Once you decide on your test set, you put it away in a box, and you don't take it out until the very end. Typically, they split train and test, then they split the train further into train and validation. Now, you may ask, what about cross-validation? Well, we will talk about that. There are some variations in this pipeline, in this procedure. What we're going to do is split the training into train and validation, and then further do cross-validation within the training set. So typically, validation, there's validation of hyperparameters, and then there's validation of the model. Okay, two steps. And we will see this in Notebook 4. Okay. All right. Okay. All right. So we have that. All right. So here it's train, run the model, run hyperparameter search inside the training set. So train is where you determine hyperparameters. Validation, compare the best tuned version of each model family and pick the winner. Test, do this exactly once to report the winner's final performance. I will say something here that it doesn't say, but you can see in the notebook, is that you should also use, I forget the name, but you should have a confidence interval on your test value. I forget the name, but but you don't want to report a single number for the final performance. You want to report a confidence interval, because every number you report, every performance number you report, in the end should have a confidence interval, a plus or minus. Okay. Right. So here it says stratify splits on the outcome when the outcome is imbalanced. In fact, stratification should take place when you choose the training and testing set. We saw that before, that especially if you have small data sets, if you don't stratify, then your training or testing set may not be representative of the correct proportions. Okay. And you do want to set a random seed, because if your models are trained depending on randomness, you want someone else to be able to obtain exactly the same model that you have. It's important to have reproducible results so other people can verify what you did. Okay. If someone doesn't believe your result and you give them your code and then they reproduce the result, they cannot argue with you. Right? Okay. All right. So address class imbalance. Okay. So quantify the imbalance. Note the failure mode of ignoring it. Okay. Choose a strategy deliberately. Okay. Class weight. So when you're training, you do need to explicitly take into account, you do need to explicitly take into account whether the class is not balanced. We talk about three techniques here. We use the one, we typically are using the first one in these notebooks. Class weight equals balanced. So this counts underrepresented classes more in proportion. There's this other method called SMOTE, which in fact is quite similar to the first one. But SMOTE creates synthetic instances based on the ones that are there. Okay? And then you can also use threshold adjustment. So there are three techniques for adjusting for the case where you have imbalanced classes. But you should use at least one of these. You might ask which one is better. Some prefer one, some prefer the other. The difference is not that much, really. Typically, the difference is not that much. You will find some people who say SMOTE is always better, and they will be evangelists for SMOTE. But you can use any one of these. We're using evaluation metrics in a way that reflects real world-class frequencies, not just the reweighted training objective. Okay. So I will explain this one more also when we go to the actual notebook. Okay. So once you've decided all of these things, once you've set up your data, once you've set up your procedure, you build a modeling pipeline. Okay. And this is done for you with scikit-learn. The pipeline includes both the data preprocessing and the preprocessing, the model training, and the model evaluation in one large package. Okay. So in this way, you can use multiple models. If you want to test different models, all you need to do is plug different models into your pipeline. Okay. So you set up the pipeline, you plug in different models, and then you can compare the different models. Again, we will be seeing this in Notebook 4. Now, you should start with a very simple model. And this is a mistake that a lot of people make. They want to use deep learning. They want to use XGBoost. They want to use the latest and greatest model. But they don't compare it to a simple model. And sometimes you find the simple model does better than the fancy model. Okay. So you always need to have a baseline model that's very simple. And this could just be something very, very trivial. You could just predict, say, the mean, something like this. Okay. But you should have something to compare your more sophisticated model to. Right. Now, if you do include more complex models, then you'll have hyperparameters that you will need to tune. Okay. Some common models in epidemiology are random forest or XGBoost. And XGBoost really is a modification of random forest. So, and there are modifications also of XGBoost. So, and this is an area of active research. So you can try different things. Okay. Right. So they will have hyperparameters, and then you tune them using cross-validation. And we will see examples. Typically, the typical method for tuning hyperparameters is called grid search. You just try different values of your hyperparameter, and then you choose the value that gives you the best result. Okay. Okay. Right. So then you can compare models rigorously. This would be done with the validation set. You would use your criteria for performance, like AUC. We've talked about this before, precision recall. Or you can also use F1 score. You can use accuracy. Okay. If you want to use your results to determine risk, you also want calibration. Okay. So let me wait to explain this one further. Okay. Sometimes you don't just want to classify yes, no. You also want to classify risk. You say perhaps this individual has 25% chance of dying before age 5, something like this. So you don't just want to classify, you want to determine the risk. In that case, this calibration curve can be important. Uncertainty, whenever you have a value again. You should have confidence intervals. So bootstrap was the word I was trying to find. You use bootstrap to find confidence intervals. Okay. So you compare on the validation set. Okay. Now, there are other tests you can do. This step really is optional. If you want to be more certain about your results, you can have results that are very good overall, but very bad on subsets of the data. So you can look at the performance on subsets of the data as well. Okay. So this will tell you that your data really, that your prediction model really does perform well on any subgroup of the population. Okay. So all of this, we've not done anything with the test set. Finally, we go to the test set here. Okay. We get the test set and we get confidence intervals using Bootstrap. Okay. All right. So here's a table that shows you the different software, the different packages that you use for different steps. Okay. So let me pause here for some questions. Let's take 3 or 4 questions now. Okay. If you have questions about this model, and then we can go into looking at the actual code. Now, I just want to make sure everyone's with me. So does anyone have a question on the procedure? I don't want to spend too much time, not more than 10 minutes on this section. Any questions? Everyone is sleeping.
Any question?
Okay. All right, so maybe I should ask you some questions. Okay.
Yeah.
What are some techniques for dealing with class imbalance? What are the 3 techniques dealing with class imbalance? Yes. Okay. Yeah.
Class width balance, smooth
Okay.
and threshold tuning.
Okay. All right. So you can do weight equals balance, but there's 2 other techniques. What are the 2 other techniques? Okay.
By encoding.
Okay. Okay. No, that's not a technique for dealing with class imbalance. That's for some other, that's not for class imbalance. That's for making variables to be comparable. But the encoding is not to address class imbalance. Okay. Everybody fails.
I think there was a time you mentioned undersampling.
Okay, no,
Yeah.
that's not for dealing, well, we did do that. That's true.
Okay.
That's a bad technique. That's a bad technique.
We have smooths, we have
Smooth, yes.
threshold
Smooth.
adjustment,
Yes, those mode and threshold adjustment.
mass width balance.
Yes, those are the 3. Those are the 3, yes. Okay. Okay. All right. So let me ask you, what set is used to tune hyperparameters? All right, you answered the first one. Okay. What set is used to tune hyperparameters? Which set? Which set? You have 3 choices: training set, validation set, test set. Which set is used to tune hyperparameters? Okay. Okay. It's training set. Okay. Which set is used to select the best trained model? Okay. Correct. Validation set. Okay. Okay. So let's see if I can think of another question. Okay. 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 Which model? Which other model is XGBoost based on? Yeah, you answer everything. I want to get somebody else. Which model is XGBoost based on?
Which model is XGBoost?
Okay, you answer everything too. We have 2 people who know everything. So let's get somebody else.
Which model is XGBoost based on? Okay. There's someone there.
Okay. Okay.
It's an improvement on random
It's
forest.
an improvement of random forest. Very good. Okay, good. So I know you all know the answer, but you just don't want the answer. All right, so let's go ahead and look at notebook 3. So what I plan to do is just do a quick overview and then let you work with it. And I think we have some assistance to help you if you run into problems. But notebook 3 has several exercises that you can do. You do need to learn by doing. So let me go quickly through notebook 3. So if you've organized your notebooks well, so what I plan to do is we'll spend some time on notebook 3, and then we'll review, and then we'll go through notebook 4. Because I believe I have 2 hours today. I have 2 sessions, is that right? Okay, so I run until, okay, all right, that's fine. Okay, all right, so I'm going to go to my notebook 3. Now, one thing you do need is you need to have the data saved in the same folder with your notebook. Remember the data I gave you yesterday. Make sure it's in the same folder with your notebook. In fact, you can put it in a different folder, but it's more complicated. Make sure it's in the same, it's easier if you put it in the same folder. Okay, so here I have my section 3 amplified. So this is what I'm going to open. And let me close this. Sorry. Okay, and let me close this. And I don't need this. So I'll move this over. And then let me make a copy. I always like to make a copy so that I retain the original. So, and that's file, and then save as. And then here I'm going to say, I'll just say, this is for me. Okay. All right, let's just fix that. Okay. All right, so personalize your copy. All right. Now, I did mention also earlier today, let me close this because we're not using this now. Okay. Let's see. I should have closed all these. Here we go. Okay. All right. So I did mention earlier in the WhatsApp that there's an additional package that you need to read data. So I hope that you have that. It's called PyReadStat. So if you don't have PyReadStat, you may run into problems. If you remember earlier in the workshop, you had to install these other packages. To install PyReadStat has the same procedure. You'll just do a percent pip install PyReadStat. The instructions are here. Okay. So you can go ahead and do this. And if you need to install a missing package, follow these instructions. Okay. All right. I'm not going to execute again. I'm just going to go through and let you do this. Okay. All right. All right. So I hope you can recognize from here some of the steps in the PDF. Okay. This is not the complete procedure, but it's the procedure leading up to the actual model implementation. Okay. Well, of course, we need to load the data. We need to frame the research question. We need to understand the variables, explore the data. Then we need to do the pre-processing, handle class imbalance. Okay. And the lab can be, if we have time, we can go and do the lab. Okay. But all of these have to do with dealing with the data, preparing the data for the actual modeling. Okay. Now, the question that we're going to look at today is which children are at highest risk of dying before age 5, based on other variables. Variables of the child and variables of the mother, also economic variables. Okay. You've seen these instructions before. I think everyone knows you can go through your notebook by shift enter, shift enter. Okay. Okay. All right. So again, you need to make sure that all of your libraries are there. Okay. I do recommend your figures, you set this to true. There's really no need, if you're using VS Code, there's no need for you to save the figures somewhere else. All this does is it changes where the figures are displayed. If you put showfigs equals true, then you have the figures in your notebook. It doesn't change any of the calculations. Okay? So this is really not part of the pipeline. This is only for our convenience. Okay. Okay. Locating the data and save it in the same folder as this notebook. Okay. If you save in the same folder, you don't need to worry about this. So if you run into problems here, we can help you with this. Okay, right. So let's see. So then after this, we're here. You can, if you look at the code briefly, you can see that you have different columns here. The columns are explained below. There's also you're going to convert date into months, and you're going to change age into months also. Change urban and rural into a numeric value. You also change female child into 1 or 0 into a numeric value. And you in education, you record don't know to NaN. Okay. So this is really a NaN. This is not structural. This means the data is missing. Okay. I don't know how someone can not know what their education is. So, okay. All right. So, all right, and wealth quintile. So this is fine. Here they're just changing the name of the variable. In the data set, it's called V190. But if you read the documentation for the data set, V190 is the wealth quintile of the person. Okay. Okay. Birth interval, the NaN means the first birth, and we will impute later with first birth indicator. This is an example of structural NaN. The NaN actually means something. Birth interval means how many months between the first birth and the birth you're looking at. I really don't know why they didn't put 0 here, because really it's a 0. But in the way they've encoded it is NaN. Okay. But this NaN is predictable. It really gives information, so we don't need to remove it. We'll just need to recode it. We'll just recode it. Okay, birth order in the original data set, it's called board. Yeah, this is more descriptive. It's good to put descriptive names for your data. Okay. Right. So all of this is really just changing the names of the data fields to be more descriptive so you can understand your data better. You're not changing the data, you're just relabeling it to be easier to see. Right, right, right. So here we have, so the research question, can we predict what children are at highest risk of dying before age 5 using information available at or shortly after birth? Okay. So this scopes the problem. Okay. You need to specify what population you're investigating. You're also going to describe what features you're going to select. So these features that you would select, this is a process. In this notebook, they've selected for you. But in a real study, you would have to select the variables that you think are important. So you can imagine that all of these might have something to do with the risk of death of a child: maternal age, education, wealth, urban, rural, birth order, birth interval, household size. All of these might affect the risk of a child dying before age 5. Classification is died before age 5 versus survived. This is binary. A child is either one or the other. Now, the metric that is decided on here is AUC ROC. Okay. Also AUC PR. In fact, remember, AUC ROC is the area under the curve for the true positive, false positive curve. This AUC PR, this is for precision recall. Okay. Now, the choice that was made here is AUC ROC. In fact, they give both. So they give both of these. One could argue that AUC PR is better because the classes are imbalanced. But it's nice to look at both. You don't have to use just one metric. You can use multiple metrics. That's not a problem. Right. Okay. So here we're not looking at causal effects. So there's an important idea in statistics called the difference between causation and association. Two variables that are associated may not indicate a causal relationship. Okay. So, for instance, you can say Well, if I just say that having black skin is correlated with living in Nigeria, okay? That does not mean living in Nigeria causes you to have black skin. It also doesn't mean that having black skin means that causes you to live in Nigeria. It's not a, it's an association. It's not, it's an association. It's not causation. Okay. So here we're not looking at causation. We're just looking at association. Causation is a very important thing, but we're not determining it in this study. Okay. Hopefully we can get to this later this week. Okay. So we're using DHS. It's a very nice data set. Okay. Okay. So here, so here's a table of the codes in the data set. So in the cell above, we've already changed the names of the relevant fields. But in the original data set, you can see the columns are labeled by some very cryptic labels. So it's better to name for the data. Okay. Now, the way that dates are coded is called CMC, the number of months since December 1899. Okay. So this is going to be a ordinal variable because it's ordered. Okay. They don't store it as a date. They store it as what's called CMC. Okay. So you can understand, here's the exercise to help you understand how CMC works. You can convert dates to CMC. Okay. Exploring the data, you should always do some preliminary exploration. Then you want to check if data is missing. Okay. You can look at some outcomes, how they depend on some variables. This is very good to get some idea of the factors that are going to be important. In this case, here they look at zone. So I think there's 6 geopolitical zones: education and wealth. And they produce graphs for these 3. So please, when you generate this, look at the graphs and see what they tell you. See if they make sense. Right. Okay. Now, here the exercise is, instead of just these 3, add sex as well. So as an exercise, you can add sex to this list. Okay. Right? Okay. Okay. So now we put together the features that we're going to use. We handle missing data that's non-structural. We encode and split, training, validation, and testing. And you can see that we use Stratify. Okay. We set the random seed. Okay. We set it as a particular value. Okay. In fact, in this exercise, you show that you get different results if you use a different seed. Okay. You address class imbalance. So you're going to make sure to use, when you do use your model, you're going to use class weight equals balance. Now here's an exercise to determine if balanced is the same as actually weighting differently. Okay. So we will not do SMOTE. There's just some information about SMOTE. Okay. Right. So I think the lab, if you have time, you can get to the lab. So what I would like to do is have you go ahead and execute this. Okay. So I do think that you learn by doing. Go through, execute the cells. If something doesn't work, we can help you debug. Look at your outputs and see and try to understand what's going on. Okay, so I'm going to stop here. I think we can take maybe half an hour to go through this. Okay, try the exercises. Try modifying the code. You need to get comfortable in changing your code. Okay, so I'll stop here, and please go ahead and start, and we will come around and help. All right. Okay. Oh, don't clap now. Now's the time you start to work. It really would be good if the other assistants would go around and monitor people's progress and see how they're doing. I think that would be very good. Sometimes people are having trouble and they don't ask questions. So those of you who are supporting the effort, it would be very good if you went around and helped. Thank you.
So, the co-facilitators, please let's go around to assist people in case they're having challenge with the codes.
Okay. So, hello, okay. So please let me quickly introduce Notebook 4 so that you can do this at home. And Notebook 4 follows very closely with the PDF outline that I started with. Okay. And the idea is for you to work through this and do the exercises so that you become comfortable with modifying the code. Then you really become familiar with the different steps. I think if you look through this, it will look very familiar. First, you check what's installed, same as in Notebook 3. If you are missing a package, you can install the missing package. I think most people have XGBoost already because we used this in Notebook 2. All right. Okay, so this one actually goes through the entire process. Or in fact, I should say that Notebook 3 does the first part of the process, setting up the data, and Notebook 4 takes the data that's been prepared and does the pipeline. Okay, so the pipeline means you start with the data with the scaling the data. Then here you can see that we start with a simple model, the baseline model logistic regression. We also introduce two models that are more complicated, random forest and XGBoost. These both have hyperparameters that need tuning. Then we compare the models. And then step 4 is more an optional case where you're looking more closely at the performance of the models. Okay. And then the lab involves writing up and making recommendations. So if we just scroll through this very quickly, this is using the same data, so you don't need to load any more data. Okay. You do need to reload your packages. Now there's several packages here from sklearn. These are the packages that are needed to construct and train and evaluate the models. Okay. All right. Again, you should put showfigs equals true if you're running VS Code, or showfigs equals false if you're running Colab. Okay. We've already located the data, so this should be no problem. And then here is reproducing the same thing that was in Notebook 3, changing the names of the different columns so that they're more legible. Okay. So that's the same thing as before. Okay. Now here we talk about the entire pipeline, from scaling the features to training to hyperparameter adjustment to validation to testing. Okay. All right. So here the pre-processing puts all of these variables on the same scale. You standardize continuous features. You binary and ordinal features can remain the same because they have limited range. And then nominal, you do one-hot encoding. So we've covered all of these before. Okay. Okay. Here there is some imputation. You remember that the birth order, there were some NAs, and this imputation will replace the NAs with another value. Okay. Now there are different ways of imputing data. I can talk more about this next time as well. This is the baseline model, the simple model that you want to use as your standard for comparison. You can see here also that it uses the AUC is going to be our evaluation criterion. Okay. AUC for the ROC and the AUC for the precision recall curve. Okay. The nice thing about logistic regression is that you can interpret the coefficients. So after you run this, so I do encourage you to run this at home. We can talk about this tomorrow. The coefficients have interpretations as odds ratios. So I can explain that next time as well. But I do want you to go through the notebook and run it. This talks about tuning the random forest and XGBoost. We talked about hyperparameters and how you need a process to optimize them. The nice thing is that you don't need to know in detail the process. Scikit-learn will do it for you. These are a list of hyperparameters. We've talked about the depth of a tree. This one is the number of trees. This one is the size of classes in a tree decision. XGBoost has learning rate and subsample. These are also hyperparameters that you can vary. And here you've got this randomized search cross-validation will optimize your hyperparameters for you. Right. So there's some decisions to make. Again, please work through the exercises and do them. XGBoost is doing the same thing. It's also doing hyperparameter tuning. Okay. There are some choices to be made during the tuning, and this is just learned from experience. Now we do the model comparison. You do a graphical comparison. You do numerical comparisons. If you want to use the model for risk evaluation, you do calibration curves. Okay. We don't have time to discuss this today, but we'll discuss it tomorrow. Okay. Then we do bootstrapping to do the final evaluation. Okay. Okay. All right, so I do encourage you as your homework to run through this also. Make sure all the cells run. Do some of the exercises. And we have about 7 minutes left. I can continue to come around and watch what you're doing. But please, don't just run the cells. Do the exercises as well. If you have questions about the exercises, we can talk about that. But this is something where you really learn by doing. Okay. All right, good. So I'm done with the explanation, and I will come around and do some more support.